Okay, so in the last class we have already studied about what introduction to dynamics means, how the dynamics is classified into statics and what mechanics classified into statics and dynamics. Then dynamics again, kinematics and kinetics. Okay, so in kinematics we have studied about particle and rigid body separately. What is particle, what is rigid body, that is already described. Then we have covered types of motion. In types of motion, three types of motions are there. One is translation, rotation, and what, general motion. And again we have covered translation motion, which is of two types: rectilinear translation and curvilinear translation. So today we will discuss with the kinematics of particles undergoing rectilinear translations. We are mainly discussing about rectilinear translation. Clear? Okay. So here what happened? In previous slide already we have explained about motion. See, what is motion? Motion means change of position of a body with respect to fixed point. See the time. Okay, change of position of a body. See here, it already mentioned here. Okay, what is motion? Motion means change of position of a body with respect to fixed point. With respect to fixed point. That means what? I have to show one fixed point so that I can trace the motion of a particle. That's why what happen? I am using what? One fixed point I am taking. Okay, suppose I am tracing the position of a particular point, means I am taking the fixed point. Okay, with respect to which I can trace the path of particle. Okay, and also we are also taking some coordinate system. We are also taking some coordinate system like that, x and y axis, x and y axis like this, where O is the origin, O is the origin, and this is known as your frame of reference. Okay, this total is referred as a frame of reference. Frame of reference, from which I can what? I can refer. I can refer. Okay, so you know this one, what is frame of reference also, and you can write also. Okay, let's write. What do we mean a frame of reference? What do we mean frame of reference? What is frame of reference? Anyone? It is defined as what? If it is a system of coordinates, I don't know, it is a system of coordinates it is a what? System of coordinates. Why it is used? To identify coordinates, used to identify what? Location and direction. A particular body at a particular instant of time where it is there. Okay, to identify what? A location. To identify a location and direction in space, or direction in space. Clear? That is known as frame of reference. This is known as frame of reference. Okay, and it is here x and y axis. This constitutes a what? Frame of reference. Clear? This constitutes a frame of reference. And in this frame of reference, what happen? What happen? You are saying about fixed point or not? On fixed point is required, na? This origin is the fixed point about which I can trace the motion of a particle. Okay, this point is my what? Fixed point. This point is known as my fixed point. Okay, and this frame of reference is also known as rectangular frame of reference, because what? X and y are perpendicular to each other, so that is also known as what? Rectangular frame of reference. Clear? Got it? Okay, So this is the first point. Before analyzing the motion of any type of motion, I have to know these things. Okay, frame of reference. And sometimes in question also, in exam also it is asking, there are two types of frame of reference are there. Okay, there are two types of frame of reference are there. One will be inertial frame of reference, another is what, non-inertial frame of reference. I can write one will be what, inertial frame of reference. It is asking in exam, inertial frame of reference. Okay, inertial frame of reference and non-inertial frame of reference. What is inertial frame of reference? What is inertial frame of reference? The frame of reference, the frame of reference which is either at rest or moving with uniform motion or uniform velocity, whatever may be, in moving with uniform velocity, is referred as what? Is referred as inertial frame of reference. Is referred as inertial frame of reference. Got it? Inertial frame of reference. That means here the frame of reference or the fixed point is either at rest at a particular point or it is moving with what? Uniform velocity. I can consider the example. What is the example? What is the example we are saying? Suppose you are sitting in inside a what? Moving train. Okay, and the train is moving with constant velocity. Then at any point on the train is considered as a what? Inertial frame of reference. I can take the example that a train moving with constant velocity. A train moving with constant velocity. Moving with what? Constant velocity. It's an example of what? Inertial frame of reference. Clear? Got it? What is non-inertial form? Next point is what? Next point is non-inertial frame of reference. Next point is non-inertial frame of reference. Non-inertial is what I can define? What I can define in non-inertial frame? I can define like this. The frame of reference which is either accelerating, that is a frame of reference that is what? That is accelerating. That is accelerating either in linear motion or rotation. Okay, either in linear fashion or rotation. Either in linear fashion or rotating around any axis, or rotating around any axis. Clear? So this is an example of what? Non-inertial frame of reference. axis is referred as what? Non-inertial frame of reference. Non-inertial frame of reference. Clear? Okay, so inertial frame of reference and non-inertial frame of reference. This is the difference. If 2 marks question will ask, then you have to write the definition along with one example. The definition along with one example, that is sufficient to get 2 marks. Okay, but you have to write it. Okay, what is the example? A turning car, a turning car with constant speed, rotating, okay, with constant speed. Clear? Got it? So this is all about your frame of reference. Once the frame of reference is over, next we have to go for what? Motion parameters. Next we have to go for what? Motion parameters. What are the motion parameters? Already I said what? Position, displacement, velocity, that you have to know in case of your what? Rectilinear motion. Motion parameters. Motion parameters are common. There will be just little bit modification in case of your what? Rectilinear motion and curvilinear motion. Okay. So motion parameters. What are the motion parameters? The first motion parameter is what? Position. The first parameter is what? Position. What do you mean position? What do you mean position? Position means the location of a particular body. The location of a particular body, at an instant of time. Particular body at an instant of time. Instant of time means at a particular instant, what is the location of the body, that is known as your what? Position. Suppose I want to define position of anybody. So position of anybody means directly by saying that, okay, let's consider an example. Okay, let us consider an example. I am considering the frame of reference again. Okay, frame of reference again. Okay, see here, this is x, this is y. Okay, this is one particle is there. Okay, and the particle is traversing the path like this. Let's see, is traversing the path like this. Okay, this particle is traversing the path like this. Clear? At a particular instant of time, let what? The particle is at this position. At a particular instant of time, that particle is at this position. That means what? I have to specify the position. Okay, so position means what? Only let the distance between them is what? Let the distance between them is from the fixed point is r. If I only specify that, let r equal to 5 meter, the body is at 5 meter. We can't reach to that particular body because from the fixed point there are number of directions are there. So along with the direction, the magnitude also, the length, magnitude and the direction has to be specified. That's why this position is a vector. This is not a scalar. That is always represented by r vector. So this is the what? Particular location of a body at a particular time at time t. Let this is what? At time t. At time t, this is the what? location of the body. Clear? Now what happened? After some time, it will move to new position. Let this is the new position. Let this is the new position. At time what? T plus delta t. At time t plus delta t. It takes delta t times. After delta t time, what happen? It will reach to this position. That means what? What is the position vector of that position? I can represent the position vector of that particular point as like this. Okay, let this like I can say what? R plus delta r. Okay, r plus delta r. This is the position of that particular time. That means what? In delta time, it is moving a extra distance of delta r. Clear? Got it? Okay. Then if I join these two lines, this will give my what? Displacement. If I join these 2 points, initial point and final point, so this gives my what? Delta r vector. Okay, and using triangle law of vector addition, what will get? What is the vector addition I get? Vector addition is r vector plus delta r vector. Okay, that is equal to what? R plus delta r vector. Clear? Got it? Or I can say what? The initial position of the body is Ri. Let Ri is known as the initial vector. This is what? Initial position vector. Okay, and Rf is final position vector. Rf is the final position vector. Then what happen? What is the final position vector? Final position vector Rf must be equal to what? Ri plus delta r. Okay, got it? Then from this equation, if I want to find out delta r or change in position with a fixed point, that equal to what? Rf vector minus Ri vector. Clear? Got it? Okay, so this delta r can be referred as the displacement of that particular what? Body. Displacement of that particular body with respect to the fixed point. Got it? Okay, so this is all about your position. Next point is what? Second point is all about displacement. Once position is over, next we'll go for what? Displacement. Second point is what? Second point is displacement. What is displacement? All you have to know about these things in +2. Okay, so again I am saying the change of particle or a body the change of what? The change of position of particle. Okay, the change of position of a particle. The change of position of a particle. What? With respect to a certain fixed point. Certain fixed reference point. Is termed as displacement. termed as displacement. Okay, got it? Or I can say it is the shortest distance. It is the shortest distance covered by the body. Shortest distance covered by the particle by the particle from a reference point. From a reference point. Okay. What is the shortest distance covered by the body? That is known as what? That is known as your displacement. Okay, but it is not equal to distance. It is not equal to the distance traveled. Displacement is equal to distance traveled only in what? Linear motion. Only in what? Rectilinear motion. Okay, rectilinear translation. Uh, displacement is always what? Less than or equal to distance traveled. Distance traveled. Clear? That means distance traveled is always more than what? What is the case whenever displacement is equal to distance traveled? In linear movement. In linear movement. In linear movement, what? Displacement and distance both are same. Displacement and distance traveled both are same. Both are same. Okay, it is a vector quantity. It is a vector quantity. Vector quantity. Okay, denoted by S. Denoted by what? S. S is the symbol. S is the symbol for what? Displacements. Clear? Or displacement clear? This displacement can be expressed as a function of what? Time also. Sometimes is this S can be expressed as what? Expressed as a function of time. Just like that. What is S? I can write S equal to what? C plus Bt. C plus Bt. That means here what happened? Here C is, here what is C? C equal to initial displacement time t equal to 0. Initial displacement at time t equal to 0. At time t equal to 0. Okay, and what is B? Rate of increase of displacement. Rate of increase of displacement. Increase of displacement. Okay, this is one bump. This example of what? It is an example of what? Rectilinear motion. This is an example of rectilinear motion. This is an example of rectilinear motion. Clear? Okay. Next we'll go for the next parameter. That is what? That is velocity. The third parameter is what? Third parameter is what? Velocity. Position will be over, then displacement will be over. The third parameter is what? Velocity. What is velocity? What is velocity? Simple definition, time rate of change of displacement. Okay, the time rate of change of position, change of position or displacement. Time rate of change of position of a body is referred as velocity. Is referred as what? Velocity. Is referred as velocity. Then what happen? What is velocity? I can say mathematically velocity equal to time rate of change. Time rate of change is d by dt of position or what? Displacement, ds by dt. That means I can say b equal to ds by dt. Got it? So this is the formula for b, and this is referred as what? This is referred as what? Instantaneous velocity. This is referred as instantaneous velocity. Instantaneous velocity. Okay. And what is average velocity? Average velocity. What? Average velocity of a particle. Of a particle in time delta t. In time delta t. What is average velocity? We know that velocity equal to what? Change in displacement, change in time, na? Okay. What is the change in displacement that particular time divided by that particular time? Delta s by delta t. This is known as what? Average velocity. But ds by dt, that is known as what? Instantaneous velocity. This is v average, or I can say here v avg, v average. Okay, v average equal to delta s by delta t. Clear? For that particular example, if I take the example of if I take the previous example, in previous example what happened? What I considered? I considered that displacement s equal to what? C plus bt, na? C plus bt. If you found the velocity for the particular example, then what is v? What is b? b equal to what? ds by dt. If you find out ds by dt, that is known as what? Duration of this equal to b. B, which is constant. So that is an example of what? Uniform motion, where b represents what? Rate of increased displacement, na? Rate of increased displacement is only velocity or not? That's why b is known as what? Rate of increased displacement. In the previous example, b is what? The constant, and b is the velocity. Clear? And what is the unit of velocity? Unit of velocity is what? Meter per second. Unit of velocity is what? Meter per second. Clear? That is clear. Okay. Next point is the fourth point. The velocity is over. Next point is what? Acceleration. Next point is what? Acceleration. What is acceleration? The what? Last motion parameter, that is acceleration. What is acceleration? Already all of you know. The time rate of change of velocity. The time rate of change of velocity. Rate of change of what? Velocity. Time rate of change of velocity is called acceleration. Time rate of change of velocity is called what? Acceleration. It is denoted by symbol what? It is denoted by the symbol A. It is denoted by the symbol A. Okay. Then A equal to what? A equal to, I can write dv by dt. Clear? Okay. So this is also known as the acceleration. And in case also, if I want to find out average acceleration, what is average acceleration? Not average, that is average. AVRAG. Average acceleration. Average acceleration. That must be called what? A average, which must be equal to change in velocity with respect to change in time. That is known as what? Average acceleration. Clear? Clear? Now, acceleration can also be expressed like this. What do you know? We have what? A equal to dB by dt. dB by dt. Okay. What is V? V equal to what? ds by dt. So, which implies A equal to d by dt of ds by dt. ds by dt. Which is what is A? A is also expressed as d square s by dt square. This is also the expression of A. d square x by dt square. Clear? This is another expression of A. Again what? Again I can express acceleration in another term also. A equal to what? dB by dt. Okay, let's multiply and divide by ds. You multiply and divide by ds, then what happen? What is ds by dt? ds by dt becomes v, and this is equal to what? dv by ds. So this is also another expression of what? A. Clear? Okay, so acceleration can be expressed like this. Got it? Okay, so these are the different parameters what we need to discuss. Clear? Okay, so next we'll discuss about, there are two types of motion mainly we study. One is what is uniform motion. One is uniform motion, what I have already studied in statics. What is uniform motion? What is uniform motion? A particle is said to have uniform motion. A particle is said to have uniform motion when its acceleration is 0. When it is moving with constant velocity or acceleration is 0. When its velocity is constant. Okay, velocity is constant. Clear? And this previous example, s is equal to c plus bt, is an example of what? Is an example of uniform motion, because I got that b equal to b. Okay, so here what happened? It is an example of what? Uniform motion. It is an example of what? Uniform motion. Clear? Okay, another point is what? Another type of motion is uniformly accelerated motion. Another form is uniformly accelerated motion. Uniformly accelerated motion. Uniformly accelerated motion. What do you mean uniformly accelerated motion? A particle is said to have a particle moving with constant acceleration. Okay, a particle moving with a constant acceleration. Constant acceleration is said to be in what? Is said to be in what? Accelerated motion. Accelerated motion. Got it? Okay. Let us consider an example that s equal to half gt square. This is the example of what? Example of a freely falling body. In case of freely falling body, this is the expression I will got. Freely falling body. I will explain. For freely falling body, the expression will be s equal to half gt square. And if I find the velocity in this case, what is velocity? Velocity equal to what? Displacement by time. Displacement time means what? Half g is constant. Half g is constant, and t square derivative is what? 2t. That is what? 2 cancel. That is equal to gt. That is equal to gt. That means velocity is also a function of time. Here velocity is not constant. Velocity is not constant means it is not example of what? Uniform motion. Okay. Then again what? Then acceleration. Now what is acceleration? Acceleration equal to what? dv by dt. dv by dt. That means what? G. G, which is a constant, which implies a equal to g, which is equal to what? Which is equal to constant. As acceleration is a constant, this is an example of what? This is an example of uniformly accelerated motion. This is an example of what? Uniformly accelerated motion. Clear? Got it? Okay. So whenever the motion is uniformly accelerated motion, for uniformly accelerated motion, certain what? Equations are there. For uniformly accelerated motion, certain equations are there. So write down a motion with uniform acceleration. Let's consider this uniformly accelerated motion or motion with uniform acceleration. Motion with what? Uniform acceleration. Motion with what? Uniform acceleration. What happened? The first only what? We know that we have what? Acceleration equal to constant. A equal to what? Constant. Very good. Okay. But what is the value of A? A equal to what? dv by dt, which implies what is dv? I can take dv equal to a dt. Clear? Got it? Let at time t equal to 0, what? At time t equal to 0, the velocity equal to what? Velocity equal to u, and at time t equal to t, what is the velocity? Velocity v equal to v. Clear? Then use the limit and integrate. Use the limit and integrating. By integrating both sides, what happen? By integrating, what integration dv with suitable limits, what? It varies from u to v equal to a dt integration, which varies from what? 0 to t. Now integration of dv is what? V. Integration of dv is what? V from u to v, and here what? Acceleration a is constant, dt integration is t, that is from 0 to t. If I use this one equation, then what becomes? It becomes what? b minus u equal to a t, or I can write v equal to u plus a t. One equation clear? First equation. This is the first equation. Then what is the second equation? All these three equations are known to you. So again I am saying, okay. So we have, what do we know? Velocity equal what? Dx by dt. Okay, which means what is ds? Not dx. Let's consider ds because we are considering always what? Ds na. So let's consider ds. Velocity equal to ds by dt. What is ds? ds equal to v dt. Okay, ds equal to v dt. That means what? Uh, at t equal to 0. At t equal to 0. What is the displacement? Displacement is also 0. Clear? And at t equal to time t, and at t equal to t, what is the displacement? Displacement equal to s, displacement s. Okay, then what I can say, by integrating what? By integrating what? Integration ds, limit is from 0 to s, equal to what? v dt. Okay, the limit will be what? From 0 to t. But what is v? V is not a constant. So I can't directly take out. So use the value of v. See here, 0 to s ds. What is v? Already we have derived v equal to what? U plus at. Okay, u plus at integration 0 to t what? Dt. That means I can say what? 0 to s ds equal to 0 to t u dt plus 0 to t what? At dt. Clear? So u is what? Velocity at a particular instant of time, so that is constant. So that is what? S is from 0 to s. Then you take common, t is from 0 to t. Then a is constant, t dt is t square by 2. From 0 to t. Now open it. 0 to s means s is equal to u t. এটা হচ্ছে কোন হাফ কমন আসিব প্লস হাফ কনস্ট্যান্ট বাহারକୁ পଳେଇଆସିଲା a constant. This is what? T square. So s equal to ut plus half at square. This is the second equation. Got it? This is the what? Second equation. Whenever what? The body is moving with the constant acceleration. Then comes the third equation. What is the third equation? We have, what do you know? Acceleration equal to v dv by ds. This equation also know. In this equation, if I cross multiply this one, a dc equal to what? V dv. Okay, by integrating with suitable limit, with suitable limits. Okay, with suitable limits. What are suitable limits? Integration a ds, and displacement changes from what? 0 to s, integral to integration v dv, and velocity changes from what? U to v. If this is the case, then what? Acceleration is constant, ds integration is s from 0 to s equal to v dv is what? V square by 2, that is from what? U to v, that is equal to your a s equal to v square minus u square by 2, which place I can write it what? V square minus u square equal to 2as. This is the what? Third expression for uniformly accelerated motion. Got it? So these are the three main equations for a body which is having uniformly accelerated motion. Clear? Got it? So these are the three main important equations: v equal to u plus at, s equal to ut plus half at square, and v square minus g square equal to 2as. Got it? These are the two main equations in case of your what? Uniformly accelerated motion. Another equation is also there. We can discuss that also. Then we will end our class. That is what? Distance covered in nth second. That is what? The fourth one. What? Distance covered or distance traveled in nth second. The fourth one is distance traveled in nth second. Travel in nth second means in a particular second how much distance is traveled. Okay, clear? So how to derive this one? How to derive this one? We know that. What do you know? What is the distance covered? Distance covered s at a particular time equal to what? Ut plus half at square. Na? This is the formula for what? Distance traveled. Okay, then distance covered in n second. Distance covered in n second. In n second. Okay, if I will take n second, then what is the distance covered? Distance covered s n equal to, I can write un. I can write un plus half into a n square. Similarly, distance covered in n minus 1 second. N minus 1 distance covered in n minus 1 second. If the time period is n minus 1, then what is the distance covered? S of n minus 1. S of n minus 1 equal to what? U of n minus 1 plus half a of n minus 1 whole square. Clear? That means distance covered in nth second. Distance covered in nth second. Nth second. That is equal to what? What I can say? Distance covered in n second minus distance covered in Sn minus 1. Na? Clear? Got this or not? Got this or not? Or let's consider this example. Let's consider this example. Okay, so this is my 0, 1, 2, 3, 4. So this is the at time t equal to 4 seconds, the distance covered will be this one. The distance covered will be what? S4 at time t equal to what? 4 seconds. Okay, and this is my what? T equal to 3. T equal to 3. That means what? This is the distance traveled by the particle in what? 3 seconds. This represents the distance traveled by the particle in 3 seconds. Na? I can represent it like this. See here. S3. So in 4th second, in the last second, in the 4th second, that means in this second, what is the distance traveled? What is the distance traveled in 4th second? Suppose someone will ask. Someone will ask, what is the distance traveled in 4 seconds? Then how to find out? Distance traveled in 4 seconds minus distance of 3 seconds. That is the distance traveled in 4th second. Na? Same here. Distance covered in n second equal to distance covered in n second minus n minus 1 second. Okay, that is the point. Clear? Okay. Now use the equations. What is Sn? What is Sn? Sn equal to un plus half a n square minus, what is Sn minus 1? U into n minus 1 plus half, okay, here it will not work, so I will write below, plus what? Half into a n minus 1 whole square, half into a bracket n minus 1 whole square. half a in bracket what, n minus 1 whole square. Clear? Now expand the equation. Expand the equation. This is un plus half a n square minus, if I explain this one, what, un minus 1 is plus u minus half a n minus 1 whole square is what, n square minus half a into 1 square is 1 minus 2n minus 1 is plus half a into 2n into what, 2n. Okay, so this un cancel out, plus half n square minus half n square gets cancelled out. Clear? Then what I'll got, u plus half a plus half a into 2n, and if I, which implies what is my essence, s n second, distance traveled n second equal to u plus half a, if I take common, if I take half a common, this becomes equal to what, 2n plus 1, 2n plus 1. So this is the value of the equation, or distance traveled in n second. So this is the expression for, this is the expression for distance traveled in n second, distance traveled in what, n second. Clear? So with this we'll end this video. Okay, so in the next video we'll solve some problems related to this rectilinear translation by using these 4 formulas. Clear? These 4 formulas are mainly used to solve the problems. So thank you. Let's end the class now.